Greetings, welcome to APchemistrycourse. Today we're going to talk about the problem solving of vsepr. So we're going to start solving now some questions related to the vsepr theory. Alright, let's start. So first things first, we have the first question. It's going to be pH3. pH3. We need to know what is the molecular structure or the shape of the molecule of pH3. Well, we're going to use these set of rules. 1. How many things? What does that mean? It means how many things that are around the central atom. 2. What is it based on? So what is the molecule based on? Or what is the compound based on? 3. How many lone pair of electrons are there? So we need to know how many lone pair of electrons are there. And what is the molecule's shape and angle? So we want to know at the end the actual shape of the compound. Alright, so let's start. pH3. We draw the Lewistown structure by starting with the central atom, which is going to be P. Put the valence electrons, we put hydrogen, single, and single with hydrogen. So we have one thing, two things, three things, and one lone pair of electrons. So we'll count it as 4 things. So here's another thing. So we have 1, 2, 3, 4 things. So how many things are there? We have 4 things. What is it based on? Well, because we have 4 things, then we look at the family chart. As you can see here, 4. What is that molecule based on? Now always remember this. You always pretend that the lone pair of electrons are a atom. So instead of a lone pair of electrons, imagine them as atoms. So at the end, you're going to have a shape which is looking like this. We have 1 hydrogen, 2 hydrogens, 3 hydrogen, and the lone pair of electrons is going to be as if it's one atom, so it will be up here. So it will have that shape. And what is it? You're right, tetrahedral. So tetrahedral, that's the shape that is based on. So we write tetrahedral. It's based on, So based on tetrahedral. Alright, let's go. Third question. How many lone pair of electrons are there? We have 3 atoms and 1 lone pair of electrons. So we have 1 lone pair of electrons. Alright, last question. What is the molecule? What is the shape or the molecule's shape and angle? So we know what is it based on, but what is the actual shape? In order to know the actual shape, we need to look at it again. We have 1, 2, 3 atoms and 1 lone pair of electrons. First things first, that would be a family of 4 because we have 4 things. Second of all, we go to the chart and we look at the shapes. Which one of these shapes has has 3 atoms and 1 lone pair of electrons? It's not tetrahedral because we just saw it. It has 4 atoms and no lone pair of electrons. Is it trigonal planar? Trigonal pyramidal. My bad. It's trigonal pyramidal. Well, let's see. Trigonal pyramidal is going to be simply this shape without the atom that is above. And it contains a lone pair of electrons. Let's see. Are they identical? Yes, they are. So the actual shape or the molecule's shape is going to be trigonal pyramidal. So trigonal pyramidal. And the last question mentions an angle. What is the angle of a trigonal pyramidal? If the bond angle of a tetrahedral is going to be 109.5 degrees, we can just try to memorize the number, but we can't remember it. In order to remember it, you can just go back to the old shape or the shape that is going to be before it, which is going to be 109.5. Alright, so 109.5. If we go to the right, you can see that we're having a lone pair of electrons, so that will push more. That means the angle will be smaller. So we can say it's 107. Of course, you need to memorize it, but that's a great way to just remember that always it should be smaller than what is it behind. Alright, so the bond angle is going to be 107. Alright, so that's the first example. Now we're going to solve faster because I showed you the way of solving, so we start solving faster so we don't waste time. Alright, second question. It's going to be SnCl2. Alright, SnCl2. Tin is going to be in the middle. 1, 2, 3, 4. We're going to have the Cl, we have one single, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Alright, so first things first, here's the Lewistown structure. We start the first rule. How many things are there? So we see that we have one atom here, one atom here. But we can see the central atom, let me write in blue. It has 2 electrons. What does that mean? It means it has one lone pair of electrons. Always remember, central atom is the only atom that will have those lone pair of electrons. We don't count anything else from any of the atoms that are bonded to the central atom. Only central atom is the needed one. Alright, so we have what is given, 2 atoms, and one lone pair of electrons. Alright, second step, what is it based on? We have 2 atoms and one lone pair of electron. That means we have 3 things, because you can consider it as the one lone pair of electrons as an atom. So that's here 3 things. And what can have 3 things? If we go to the family of 3, we can see this shape, the bent shape. We have 2 things and one lone pair of electrons. But is it based on that shape? No, it's not. How did we know? Because we said we need to count the lone pair of electrons as an atom. Another shape, that one. 3 atoms bonded to the central atom. Does that look similar? You're right, it does. So we can say that the tin chloride is based on this shape. You can see tin is right over here, and we're going to have chlorine, and the lone pair of electrons, we can count it as an atom, so we have an atom here. So it has that shape. What is that shape called again? You're right. A trigonal planar. So it's based on trigonal planar. Alright. Next, how many lone pairs of electrons are there? Now we can count them. So we have 2 atoms and one lone pair of electrons. Great, now we know the number. Number 4, what is the molecule shape and the angle? Alright, so we said that it's based on a trigonal planar because it has 3 things. Alright, so at first we counted the lone pair of electrons as an atom. Now we don't count it at all. Now we need to find a shape that has 3 things, 2 of them as atoms and 1 of them is a lone pair of electron. Trigonal planar isn't. What about bent? Bent has 2 atoms and 1 lone pair of electrons. Perfect, which is going to be that one. So we write that we're going to have a bent with a bent that has an angle. So we have a bent and has an angle of, if that has 120 degrees, then that one's going to have approximately 116 degrees. Alright, you need to memorize those numbers, but it's just like a simple way to just remember what is the number. It's always less than the shape that is before it. Alright, so bent. But here we have a bent with 1 lone pair of electrons. Alright, so we solved the second question. Third question. Let's start solving the third question. Alright, so the third question is going to look scary, but it's not actually scary, which is going to be the formaldehyde, which is going to be CH2O. Alright, CH2O, how can we draw it? Central atom, 1, 2, 3, 4. Alright, now we're going to have, well, let me keep some space, CH2O. Now we're going to have hydrogen and hydrogen, hydrogen, single, hydrogen, single. Then we're going to have oxygen. So oxygen, if we go right over here, so if we draw 1, 2, 1, 2, 1, 1, we're going to have, so let me do it in that position. So we have 1 and 1. So we have double bond. So it's going to look like something like this. C, we're going to have H, H, and O. Alright, so we can see here's the Lewistown structure. Now, how many things are there? First things first, we see that we have 1 atom, 2 atoms, 3 atoms, bonded to a central atom. Okay, second of all, we see that for another thing that we don't have no lone pair of electrons in the central atom. That's a great thing. So we can write our givens. Always write your givens. We have 3 things, so we have 3 atoms, and no lone pair of electrons. Alright, next step. What is it based on? We have 1, 2, 3. So I have 3 atoms. Now because it has 3 atoms, we go to the family group of 3. Does the band have 3 things? Yes it does, but 2 atoms and 1 lone pair of electrons. We have 3 atoms, and we can just say that we have no lone pair of electrons, so we can't just say the lone pair of electrons is an atom because there are no. So we're going to have 3 atoms. So we leave that shape and we go to the other one. A trigonal planar. Trigonal planar, carbon. Then we're going to have the oxygen, of course we need a double bond, and then the hydrogen and hydrogen. It has this shape. What is that shape based on? I mean, what is that shape? So this shape is called trigonal planar. Trigonal planar. Alright, so it's based on a trigonal planar. Let's go now to the third question. How many lone pair of electrons do we have? Nothing. So we have 0. Great. Last question. What is our molecule shape and its angle? So what is the original shape and what is its angle? Now because we have no lone pair of electrons, and we are sure that we have 3 atoms only, so we'll take the molecule that we used as it's based on, trigonal planar, because it's the most logical and the only option we have. So it will have that trigonal planar shape. So it's going to have a trigonal planar shape. So it's going to be here. Hydrogen, hydrogen. What is a bond angle? Bond angle, now we need to memorize it. It's simple. It's going to be 120 degrees. Alright, great. For some of you who didn't watch my previous video, we talked about introduction about the rules of vsepr theory. You might be surprised right now, why didn't I just change the shape because of or why didn't I count the number of bonds between carbon and oxygen? Because simply the number of bond doesn't affect the shape. That's why. Alright, next question. So, next question is going to be SO2. Alright, SO2. So, first things first, we draw the Lewistown structure. We're going to have 1, 2, 3, 4. We're going to have 5, and let's say here. Alright, we have oxygen. So we're going to have here single, oxygen, 1, 2, 1, 2 here. And then we're going to have another single right over here, 1, 2, 1, 2, 1. And we can see now that's the vsepr, this is the Lewistown structure. Alright, so let's start. First things first, how many things are there? We have 1, 2. Central atom. Central atom, we can see there are 2 pairs of lone pairs of electrons. We can see we have 1 right over here and 1 right over here. So, how many things do we have now? 1 atom, 1 lone pair of electron. So that's 2, 3, 4. 4 things. So we write 4 atoms and we're going to have 2 lone pairs of electrons. So that would be a total. Oh, sorry. 2 atoms. So that would be a total of 4 things. So write 4 things. T for things, for example. Alright, we go for the second question. What is it based on? So, what model has 4 things? Not that, but that. So, we have that first shape, which is going to have 1, 2, 3, 4, which is going to be called the tetrahedral. Tetrahedral has 4 things. Right over here, we said always, whenever we're choosing for what is the model that it's based on, we count the lone pairs of electrons as atoms. So we have 2 atoms here, and let's say 2 things here. That would be an equal of 4 things. Let's say there are 4 atoms. So it will look like this without the lone pair of electrons. We're going to have that tetrahedral shape. So it's going to be based on a tetrahedral shape. Tetrahedral. Alright, so we know now what is it based on. Now, how many lone pairs of electrons do we have? We have 2 lone pairs of electrons, right over here. Alright, next, what is the molecule shape and angle? So what is the original shape and angle? So now we can count the 2 lone pairs of electrons as 2 lone pairs. Alright, so now we can count them. So we have now one atom, 2 atoms, 2 lone pairs of electrons. So that means you need to find a shape that has 4 things. 2 of them are atoms, 2 of them are lone pairs of electrons. We go to that chart of family 4. Tetrahedral, nope, it has 4 atoms. What about the other shape? We have 1, 2, 3 atoms and 1 lone pair of electrons. Does that apply? 1 atom, 2 atoms. Oh, we have 2 lone pairs of electrons. What about the third shape? 1, 2 atoms, 1, 2 lone pairs of electrons. Does that apply? Well, yeah, it does. So we can apply it to this shape. But what is that shape called? Well, it's called a bent. Yes, although we have a bent in 3 things, but we have a bent for 4 things, but has 2 lone pairs of electrons. The previous one had 1 lone pair of electrons. That one has 2 lone pairs of electrons. Alright, so it's based on a bent, but has 2 lone pairs of electrons. So what is a bond angle? Bond angle is going to be the first member in the 4th group has a 109.5 bond angle degree. The other one is going to be the trigonal pyramidal. We said it has approximately 107. What about bent with 2 lone pairs of electrons? Because that one is 107, then it must be less than 107. And we memorized it, so it's going to be approximately 105 degrees. Approximately. So it has 105 degree bond angle degree, and it's based on a bent shape with 2 lone pairs of electrons. Alright. I would recommend writing bent with how many lone pairs of electrons, because there are 2 types of bends. Alright. So next question is going to be really simple. Carbon dioxide. CO2. Alright. So carbon dioxide, we draw the Lewistown structure. 1, 2, 3, 4. I'm going to have 2 oxygen atoms. So oxygen right over here. I'm going to have 1. Then I'm going to have right over here. And we're going to have 1. Alright, so I'm going to have 1 single. Alright. Then we're going to have another single here, so that will be equal to 2. So we have a double bond. Next, 1 single, 1 single. That will equal to 2 double bonds. So we have a double bond. So it will have a double bond to look like something like this. CO. Just like that. Alright. So let's start. How many things are there? 1 atom, 2 atoms. Central atom, any lone pairs of electrons? No, there are no. Alright. So we have 2 things, and there are 2 atoms. Great. Next thing, what is it based on? We said it has 2 things, so we go to the family of 2. Luckily, it's going to be only 1 member, and it's going to be really easy to solve. And simply, we can just say it's going to be based on a linear linear shape. Now, how many lone pairs of electrons are there? Are there any? No, there are no. So, we have 0. Last question, what is the molecule's shape and angle? Now, because we have only two things, again, two atoms, and no lone pairs of electrons, so we're going to always relate to the first model that we found, which is going to be the linear, because it will be the only answer that we'll have. So it's going to be a linear. Oh, my bad. We ran out of ink, but it's fine. Alright, so we're going to have linear, and it's going to have a bond angle of, so if this is a linear has a bond angle of 180, because we have oxygen here, double bond, so we're going to have 180 degree for a linear. Alright, so next question. So the next question is going to be Ch4 methane. Ch4. Alright, we draw the Lewistown structure. 1, 2, 3, 4. Hydrogen here, so we have single. Hydrogen here, we have single. Hydrogen here, single. And another hydrogen here, single. From that shape, first rule, how many things are there? There are 1, 2, 3, 4. Central atom. Any lone pairs of electrons? There are no. So, no, we can just write 4 atoms. Next, what is it based on? So in order to know what is it based on, we count 1, 2, 3, 4. We go to the chart. What family has 4 things? Here. So what can it be based on? A shape that has 4 things, and they're going to be here. That's going to be a tetrahedral. Why? Because we have 4 things, 1, 2, 3, 4, and we have no lone pairs of electrons to count them as what's called atoms. They will still be counted as atoms, and it will always be the tetrahedral, because at the end we're going to count them as if they're atoms. Alright, so it's going to be a tetrahedral. Right, tetrahedral. So that's the shape that's based on. How many lone pairs of electrons are there? Any lone pairs of electrons around the central atom? No, there are no. Great. Number 4, what is the molecule shape and angle? So, because again we have no lone pairs of electrons, we can just choose again, because we have 4 things, we're going to choose again tetrahedral, or the shape that we took first. Tetrahedral. So, tetrahedral, let's draw it. Here, here, and here. What is the bond angle now? For tetrahedral, we just memorized it, and we mentioned it before, it's going to be 109.5 degrees. Alright, great. So that's the shape. It's going to look like this. Alright, great. Next question. Anyways, alright. So the next question says, we have Ammonia Nh3. Alright, Lewistown structure. Hydrogen, single, hydrogen, single, hydrogen, single bond. Alright, so first things first, how many things are there? 1 atom, 2 atoms, 3 atoms. Oh, do you see something in the central atom? Yes, we do see something, which is a lone pair of electrons. So we're going to have a lone pair of electrons, and we can just say now how many things we have. So I have 3 atoms and 1 lone pair of electrons, so that would be a total of 4 things. So I have 4 things. 3 of them are atoms, and 1 is going to be lone pair of electrons. Alright, great. Next, what is it based on? We need to find something that has 4 things, because now we need to count the lone pairs of electrons as if it's 1 atom. So we need to find a shape that has 4 atoms in it. Alright, we go to the family of 4 things. First thing, alright, you already guessed the tetrahedral of how, because we repeated it so many times, we just know that 4 things is going to be based on tetrahedral. So we have tetrahedral. Alright, tetrahedral. Next, how many lone pairs of electrons do we have? You're right, we have 1 lone pair of electrons. Now we can count, sorry, we didn't put E minus. Now we can count the lone pairs of electrons as a thing on its own, not as part of an atom, or not as a fake atom. Alright, so what is the molecule now? What is the molecule shape and angle? Now we can use the lone pairs of electrons to find a compound shape that has 3 atoms and 1 lone pair of electrons. Let's go to the family of 4 things, always 4 things. You know what, I would always give you a hint or a good advantage. Always write the total as things, as T things. So 3 atoms, 1 lone pair of electrons, so that would be 4 things. So if you're trying to find out what is a base or what is the number of things that are in the chart, you just look at this. So we have 4 things, so here. Tetrahedral doesn't work, has 4 atoms around it. No lone pairs of electrons. Next, we have 3 atoms and 1 lone pair of electrons. Does that apply? 1, 2, 3 atoms and 1 lone pair of electrons? Yes, it does. What is that shape called? You're right. Trigonal, pyramidal. So trigonal pyramidal. And in that way, we need to know the bond angle. So trigonal pyramidal going to have a shape of, an angle of, as you said, approximately 107 degrees. Okay, great. So let's go to the next shape. Next shape is going to be simple. We have 2 more shapes. Water, hydrogen and oxygen. H2O. Oh, the wrong pen. Alright. So water, we draw the Lewistown structure. We have oxygen. 1, 2, 3, 4. 1, 2. Then we have hydrogen. A single bond. And we can start right now. How many things are there? 1 atom, 2 atoms. Oh, the central atom has something. You're right. We have 2 electrons here, so that's 1 pair. 2 electrons here. You're right, another pair. So I have 2 lone pairs of electrons. So what should we do right now? You're right, we write them down. So we have 2 atoms, 2 lone pairs of electrons, and that will equal to 4 things. Great. Next, what is it based on? We need to find a shape that has 4 things. So in order to do that, we go to the family chart, 4 things. And always remember, things, when we say 4T, we always think about it as only atoms. Even if we have 2 lone pair of electrons, we think about it atoms because we're trying to find what is it based on. So we have 1, 2, 3, 4, tetrahedral, as you said. Alright, tetrahedral. So tetrahedral is the shape that is based on. Next, how many lone pairs of electrons do we have? Now we can count them. We have 1 and 2. So we have 2 lone pairs. 2 lone pairs. Alright. Now, what is the molecule shape and angle? Now we can use the data that's given to find the shape. We need to find something that has 4 things, so to be in this family, but has 2 electrons, 2 lone pairs of electrons, and 2 atoms. Let's see. Tetrahedral, impossible. Trigonal planar, 1, 2, 3 atoms and 1 lone pair of electrons. Also impossible. What about the bent? 2 atoms, 2 lone pair of electrons. You're right, it's the only choice we have and it's the correct one. So we're going to have a what? Bent. But what type of bent? You're right, 2 lone pairs of electrons type. So we can draw it like that. That's water. Going to have it here. What is the bond angle? Wait. Bond angle? You're right, approximately 105 degrees. Okay. So I think it won't be that shown in the camera, but it's 105 degrees. Okay. Last question is going to be selenium chloride. SeCl2. Now I would like you just to try to solve it on your own. Are you ready? Go. Alright. So first things first, we draw the Lewistown structure. Selenium. So it's going to be 1, 2, 4, 1, 2. Chlorine time. We're going to have one single. And we can start now counting how many things do we have. So we have 1 atom, 1 atom. What do we see in the central atom? You're right, one pair, one pair. So we have 2 pairs of lone electrons. So we write 2 atoms, 2 lone pairs of electrons equals 4 things. Now, what is it based on? 4 things. We look at the shape. First one appears, it's going to be tetrahedral, so we write a tetrahedral. Alright, next. How many lone pairs of electrons are there? 1, 2, you're right. Then, what is the molecule shape and angle? Now we can just find the shape again. We go to the 4 things because it's written 4 things. 4 things here, not that. Tetrahedral has 4 atoms. The trigonal pyramidal has 3 atoms and 1 lone pair of electrons. Last one, you're right, it's going to be bent. Bent. Voice correct. Anyway, 2 lone pairs of electrons. 2 lone pairs of electrons. And it's going to look like this. It's going to look like this. Bond angle is going to be, as you said, 105 degrees. So this is the final shape, which is going to be bent. So this is all about our lesson for today. It's going to be solving, and I hope it was useful. Have a great day.